Right. There was a small issue with the camera. Ammonia. We were doing the structure of ammonia. As usual, there you go. Nitrogen in ammonia is the central atom. 3 hydrogen are there. You draw the 3 hydrogen around it. Nitrogen valency is going to be 3. Why? Fifth group, no? Fifth group element valency 3. Valency 3 means it likes to build 3 bonds. All these 3 bonds will be made with the hydrogen. All these 3 bonds will be made with whom? With hydrogen. Pretty simple. Now what? Check how many electrons are remaining. Nitrogen is fifth group element. Then 5 electrons are there around it in the last orbital. 3 electrons are used for bonding, means remaining 2 electrons. There you go, you keep the 2 electrons. That's it. Next one, methane. 1 carbon, 4 hydrogen means carbon is the central atom. Around carbon, there are 4 hydrogen atoms. Around carbon, there are 4 hydrogen atoms. Next one, check the valency of carbon. Valence of carbon is 4 because it is a fourth group element. That means it will be 4 bonds. With all the hydrogens, it will be building 4 bonds. Now what? Check how many electrons are remaining. Fourth group element means 4 electrons are there in the outermost shell. All the 4 electrons are used for bonding, means no any remaining electrons. So you can call no unpaired or unbonded electrons. No unbonded electrons. Last on carbon dioxide, I think carbon dioxide structure is what is asked. Carbon dioxide, 1 carbon, 2 oxygen. 1 carbon, 2 oxygen. I'll draw it in the other side. I'll draw it here. Carbon dioxide, 1 carbon, 2 oxygen means carbon is the central atom. 2 oxygens are there around. 2 oxygen atoms are there around. Carbon group number 4, valency 4. That means carbon likes to form 4 bonds. Oxygen, group number 6, valency 2. So 1 oxygen likes to build 2 bonds. Oxygen likes to build 2 bonds. Carbon likes to build 4 bonds. Oxygen likes to build 2 bonds. Carbon likes to build 4 bonds. Now how to carefully or symmetrically separate these? 4 bonds carbon likes to build. Out of that 2, 2. That means 2 here, 2 there. Now what? Check how many electrons are remaining. Carbon, fourth group element. That means its last orbital there are 4 electrons. All the 4 electrons are used for bonding. Oxygen is sixth group element. That means 6 electrons are there in the outermost shell. Out of 6 electrons, 2 electrons went for bonding, then remaining 4 electrons. Remaining 4 electrons. Same story for this oxygen also. Same story for this oxygen also. And only one more molecule is there in your syllabus. Only one more molecule is there to learn the structure in the syllabus. What is it? What? Yes, and tell me what is the central atom? Oxygen. Oxygen, 1 oxygen, so oxygen is central atom. 2 hydrogen are there. 2 hydrogen are there. Purposely, I will draw the 2 hydrogen, it will be below oxygen. I'll tell the reason in a little bit. Purposely, I will draw the 2 hydrogen little below oxygen. Again, what? Check for the valency. Oxygen is 6th group, valency 2. Valency 2 means it will build 2 bonds. 2 bonds equally distributed between the 2 hydrogens. Hydrogen will have no any remaining electron. Then you need to check for the remaining electrons in oxygen or unbonded electrons in oxygen. Oxygen is 6th group element. That means 6 electrons are there in the outermost shell. Out of 6 electrons, 2 electrons have gone for bonding. Then remaining 4 electrons are unbonded. Remaining 4 electrons are unbonded. And people, sometimes you might ask, so can't we draw in one straight line like this? Can't we draw in a one straight line like this? What I would tell is in O-level syllabus, this is okay. This linear structure is okay. But remember, the most appropriate structure is this angular structure. This structure is called angular structure. Water has angular structure or angular shape. Therefore, we draw it like this because these free electrons will push the bond downwards. Free electrons on oxygen, it will push the bond downwards. So bond is little bit bent. As the bond is little bit bent, it makes a V shape. That's why we usually draw water. There you go. That's all you have in your syllabus. What are structures? Hydrogen, chlorine, oxygen, nitrogen. So remember, nitrogen is the only molecule which has a triple bond. Next, ammonia, methane, carbon dioxide, water. What I would tell is take a bristle board. Draw all these structures and paste it in front. Automatically, these structures will go inside your mind. That's the best way. Otherwise, okay, now I have told you shortcut methods how to draw this. So using the shortcut methods, you can quickly draw, right? So in the 2017 paper, they have asked the Lewis structure of carbon dioxide. Carbon dioxide Lewis structure is this is the Lewis structure. Take a screenshot or something so that I'll erase it. So remember, all these 8 structures should be there in your mind before you go to the exam. Before the day of the exam, all these 8 structures should be there in your mind. Right. That's the theory and the revision part of Lewis diagrams. Basically, these are called Lewis structures. Using Lewis structures, you can even draw Lewis dot and cross diagram. So, Roman number 4, they are asking for the Lewis structure. Lewis structure of carbon dioxide is what? Carbon double bonded oxygen. There you go. How many electrons are remaining? 1, 2, 3, 4, 1, 2, 3. There. That's the structure. That is Roman number 4. Roman number 5. Diamond and graphite are main allotropic forms. Okay. Of carbon. First of all, what is allotropes means? Remember, allotropes means a certain element that exists in different forms. A certain element that exists in different form. Now, for example, sometimes now you are there at your home, you are there. Sometimes at your home, your mother might be calling you with a different name. Now let's take your name is Saksarani. Your name is Saksarani. Your mother might be calling Suduputa, right? So sometimes she might be calling Suduputa. The father might be calling Chutikella, right? Different names. In your school, you might be called. They might be calling Ado, Warembangkand. So like that, same person, different names you are going to call because they see you in different ways. They see you in different ways, but the same person. This is basically allotropes means. Allotropes means same element but different forms. So for example, carbon, same carbon. It can show forms of graphite. It can show forms of diamond. So carbon, graphite, and diamond are 2 allotropes of carbon. So remember, allotropes means same element but different forms. So here they are talking about allotropes of carbon. Diamond and graphite are main allotropic forms of carbon. Which of these allotropic forms conduct electricity? Remember, this is very simple. The only non-metal that conduct electricity is carbon graphite. Only non-metal, carbon is a non-metal that conduct electricity is carbon graphite. So remember, graphite is the allotrope that can conduct electricity. Answer for 5 is graphite. This paper is very easy. They actually tell you. Because most of the things are given. See, they are talking first question. They are talking about second period. They are given all the element, but not in order. You have to make it in order. So they are given it and ask you to write it. Question number 5 also they are telling diamond and graphite are the allotropic forms. They are telling it, and they are asking out of that what conduct electricity. So you have 50% of chance of getting the correct answer. Fifth answer. What are your only 2 answers? Fifth question. What are your only 2 answers? Diamond or graphite. So you have 50-50 option there. So this paper is very simple. Huh? Question 6. From the elements in this period, write respectively the element which has the lowest first ionization energy and the element which has highest first ionization energy. About first ionization energy and electronegativity. Yeah, lowest first ionization energy and the element that has highest electronegativity. About first ionization energy and electronegativity, I'll discuss separately. Yeah? Now, today, if I go to discuss, there is another section I want to discuss. So, if I go to discuss, it will become a very long discussion. So, about electronegativity and first ionization energy, I will discuss separately and teach all the shortcuts. Most of you got it correct. Might be you know the theory, or might be you just guessed it. So, lowest first ionization energy, you need to write it now. Lowest first ionization energy is lithium. Highest electronegativity is fluorine. We can even give the symbol, no problem. Lithium fluorine. No issues, huh? Right? You can use the symbols. So about it, I'll discuss separately. The following questions are based on the experiment of producing a sample of oxygen gas in lab. Among the compounds given below, which compound can be used to produce oxygen? Very good theory part you can discuss. Very good theory part you can discuss. In our syllabus, you need to know production of 3 gases. One is how to produce hydrogen gas in lab. Second, how to produce oxygen gas in lab. Third, how to produce carbon dioxide gas in lab. These 3 gas productions you should know. About hydrogen gas, I have taught you separately in acid basis vessel. Can you remember? I taught you. I think acid special point 1 and acid special point 1, refer the note and see. Whenever when an acid reacts with a metal, what is formed? Hydrogen gas is formed. When an acid reacts with a metal, what is formed? Hydrogen gas is formed. For example, zinc with HCl. Hydrogen gas is formed and the salt, zinc chloride, will be formed. So that part you all know. So about hydrogen gas production, I'm not going to discuss. Here they are talking about oxygen gas production. Here they are talking about oxygen gas production. Remember in our syllabus, oxygen gas can be produced in 4 ways. Only 4 ways are there. Only 4 ways are there to produce oxygen gas. What? Decomposition of potassium permanganate, KMNO4. When potassium permanganate decomposes, there you go, K2MnO4, MnO2, oxygen is released. There you go, you can produce oxygen. This is the first one. And this is the most important method, and this is the usually used method in lab. Second method, decomposition of potassium nitrate. When potassium nitrate decomposes, potassium nitrite is produced. You can see 3 oxygen to 2 oxygen. Then remaining oxygen will be released. There you go. You can produce oxygen. Next one, decomposition of potassium chlorate. When potassium chlorate decomposes, potassium chloride plus oxygen. I'm not going to balance the equation. So we can see oxygen is produced. Last method, fourth method, decomposition of hydrogen peroxide. When hydrogen peroxide decomposes, water and oxygen are diluted. 4 methods to produce oxygen in lab. These are the only 4 in our syllabus. Potassium permanganate decomposes, potassium nitrate decomposition, potassium chlorate decomposition, hydrogen peroxide decomposition. Right? So you can clearly see one thing common to all these production methods. What is it? All are decomposition reactions. All are decomposition reactions. All are decomposition reactions. Okay. Among the compounds given below, which compound can be used to produce oxygen gas? Calcium carbonate, potassium permanganate, magnesium sulfate. So you can clearly see answer is potassium permanganate. Roman number 1 answer is potassium permanganate. This is yours. Right? So you can memorize it like this. 3 potassium containing compounds, 1 hydrogen peroxide. 3 potassium containing compounds, 1 hydrogen peroxide. I would recommend to fully memorize the reactions and keep in the mind. They won't ask for the full reactions, but sometimes they can give you to fill in the blanks. They might give you potassium nitrate decomposes blank. Then you should be able to write this. So like that, I would recommend you to memorize these reactions. Only 4 reactions now. How to produce oxygen in like potassium permanganate, potassium nitrate, potassium chloride, hydrogen peroxide. All are decomposed. So you just memorize it and keep. It is rather better. Roman number 2. Roman number 2. Write down the ones you need. These are the summary points. These are the review points you need when you are answering the next questions. Oxygen production. 4 methods to produce oxygen. Roman 2. What is the type of reaction that takes place during the production of oxygen gas when only compound you stated above is used? What's the method? Decomposition reaction. Decomposition reaction. This is the reaction taking place. Decomposition reaction. Roman number 3. Which equipment must be placed? Must be used to place the compound to carry out the experiment. Remember, decomposition means you are heating. Then you need to put the potassium permanganate crystals into some instrument and heat it. Best instrument is boiling tube, because boiling tube can withstand heat. So boiling tube is best. Boiling tube is the best one. Boiling tube is the best one. But also remember, you can use test tube. Boiling tube is the best one, but also you can use test tube. Right? Boiling tube is the best one for any decomposition reaction. Test tube also you can use. What is the name given to the method that is used in lab to collect oxygen gas produced in this experiment? What is the name? Shall I write it here? Roman number 4. Remember, in this method, oxygen is produced. This oxygen that is produced is sent in a beehive shell. I'll erase and draw it. You produce oxygen and you send it through a delivery tube. You send it through a delivery tube. Or delivery tube, when I tell delivery tube, don't think something that you can use to baby delivery, not baby delivery. This delivery tube. Delivery tube, there you go to a beehive shell that contains water. In that you have placed water. So this is water. This is water. Now we are going to send oxygen through this. On the right, oxygen is coming. Oxygen is coming. Oxygen is coming. Remember, oxygen is a gas. When a gas enters here, I will only draw the gas bubble. By experience, you all tell me, what will this gas bubble do? Gas bubble will go up. Just take a fish tank, you send some oxygen from bottom, gas bubble will go up. Gas bubble goes up. Gas bubble goes up and fills the space here. Gas bubble goes up and fills the space here. If the space here is filled by gases, what will happen to the water level? Water level will go down. When oxygen goes and fills this space, water level will go down. What do you call it? downward displacement of water. Water is getting displaced down. Downward displacement of water. Downward displacement of water. I didn't give marks for the ones who wrote only downward displacement. Because downward displacement means something is getting displaced down. For example, a marker displaced down. A paper displaced down. So downward displacement is something is just going down. You need to correctly mention what is getting displaced down. Water. So downward displacement of water. That is the correct answer. If you just write downward displacement, no mark. And some of you wrote even upward displacement. Remember, water cannot get displaced up due to oxygen gas. No? You send a gas through water. Will that gas lift the water up? No. Water cannot go up due to a gas. Gas will only go up and send the water down. So that is going to be downward displacement of water. And that marks the end of the discussion. Okay, no? So triple T 15 done. Next week, get ready for triple T 16. I will send the lessons to the group. Study those lessons and get ready. So now start working. Okay then. See you soon. Bye.